Audio's good. Do you have a wireless, or is this it?
There should be a wireless underneath the desk.
Let's see if here we go. Let's see, if I'd use the wired one, I'd be on a shorter leash than my ex-girlfriend kept me on. All right. Should I go ahead and start now? Thank you all for coming today. The talk track was, I was swapped in last minute. How many of you actually know what presentation you're here for today? Okay, I see 3 hands. That's good. This talk is going to be about how to create a dynamic footprint or inventory of an organization's internet exposed attack surface. There's 2 focuses of this. One is for external penetration testing and red team activity, and the second is for you as a corporate organization simply to keep an eye on your assets and decide what to prioritize around testing. So why are we here today? That's a good question. Let me get my... All right, how many of you picked the wrong room?
What's your name?
So this presentation is about, I'm going to get there.
We stop you. I got to check the title. What's your name again?
My name's Arian.
Aaron?
Yeah. It's on the website. This presentation is a result of a number of years of dealing with gap analysis on where breaches are occurring and why we don't know about those assets or systems when breaches occur because of things that we don't know about. So my name is Arian. My background is I started on the software development side in finance, and I built some of the first apps that move real money around on the web. So I got to meet the Russians early on, and the Ukrainians, and the Secret Service, and these folks. So I've spent about 18 years doing security, about 15 years doing pen testing. And what I wanted to, before we get started here, I wanted to get an idea of context. I was told there's a pretty broad experience of folks that come here to DerbyCon. How many of you in the room are penetration testers, do that for a living? How many of you do some sort of red team or vulnerability management in your organization? Okay. How many folks here, it's your first year doing this? You're brand new to the pen test world. A couple folks. How many of you have more than 5 years of experience doing penetration testing, red team? Quite a few. Any of you have more than 10 years of experience doing pen testing? A couple people? Okay. How many of you do external penetration testing as consultants for customers? How many of you do red team for an actual organization that you're trying to defend? Okay, so even mix. All right, well, let's jump into this. I got a lot of slides, and what you will get out of being here today is I'm going to talk about some components that you should think about adding, the ones I consistently see missing from red team scoping. And at the end, we're going to talk about there's some tools and data sets that we're thinking about releasing to the community. And I want to get some feedback from you all on what would be helpful in your organizations from a data set perspective to maintain a more accurate inventory. So our agenda, the first thing as an overview, the world we live in today, it sounds like we've got a more experienced room in here, so you probably already know all this, but the world we live in today is moving increasingly towards focusing on digital channels. Most of the organizations we work with, our web is a predominant digital channel they do business over. About 55% of financial transactions today occur through digital channels that are increasingly external to the perimeter. So when we map out our traditional network tests, we focus a lot on the perimeter, and yet where the money is flowing and the transactions occur are increasingly external through one of these channels. And so a couple of the problems we face, given we have a more experienced room, again, you should probably all be aware of this, but our perimeters are decentralizing at an extremely rapid rate. Dr. Dan Greer said that basically the notion of a perimeter is doubling every 18 months today, and the rate of that's accelerating. The pieces we need to maintain an accurate inventory of the assets that potentially could be breached or used in a chain of breach are often decentralized in organizations. Legal often owns the domains. Marketing knows about brand and logo and keywords, and these are all key components we should be using to map out and profile an organization. And these groups typically, we find, don't actually work together. The SOC and incident response people, for example, often maintain a passive DNS database, and the red and vuln teams often don't even know that they have access to that resource, and that's a pretty essential resource in finding assets. Attackers are organized and well-funded. Most organizations, when I first talk to them, have a very delusional self-image of what they look like on the internet. They think they have this nice hardened perimeter and have their asset inventory under control. And on average, we find about 35% more assets on the internet doing some form of business than the security team realizes they have. It can be as high as 4 or 5x, but it's usually a pretty substantial weight gain than they perceive in their own heads. Most of the organizations I talk to today still treat their external internet-facing security and pen testing programs as an annual snapshot. They might run vuln management and vuln scans on a regular basis, but there's this notion of an annual pen test. And that always seems kind of weird to me that we would have some, try to figure out where problems are when breaches happen from these old kind of stale Polaroids that might be a year old. In most other areas of security, we do continuous monitoring. In our physical building security, we do continuous camera monitoring. We log key card access. We log internal logging with SIMs and such. And so looking at our assets from the outside in a once-a-year model seems kind of it's a little old in this day and age, especially the way as rapidly as we develop software. So 3 other annoying issues when trying to create an accurate inventory or digital footprint of everything out there that you need to test. First of all, once you get out there and start looking around, you'll find it's actually one of the first challenges is there's so many impersonating apps and rogue applications, especially in the mobile world, that can be really hard to figure out what's actually you versus what's out there impersonating you. If it's impersonating you or the organization you're testing, it's probably up to no good, but you got to figure out what's real and what's not. And the other one is, again, when I talk to orgs, they usually, anything outside their perimeter, they usually have absolutely zero monitoring in. So they don't actually know what's going on in the middle of the night. I know the picture is hard to see there, but basically the guy on the right is Chinese. That's a bad joke. The third really annoying thing, and this is the one that actually is the most amazing to me, because this has been growing for a decade, but it's the rapid growth in client-side code and third-party libraries. When we look at a given web application or asset, increasingly large amounts of it can be 3/4 of the application is code that we've pulled down that's written by strangers, often by people in Eastern Europe that aren't our friends. And increasingly, this is all these interactive DOM JavaScript libraries. And why that's interesting is the fundamental model by which we develop software has changed. Security in the SDLC is not has not evolved to be able to address this. And what I mean by that is we increasingly dynamically load libraries off other people's systems and other people's CDNs at runtime. So the notion of doing a source code review or any sort of a snapshot or even looking in a build server at a library if you're not hosting it is kind of irrelevant, because security only matters at the runtime of the user session when the document is actually built. And most CISOs that I talk to don't have any tools or visibility, and actually they're not even aware of how much is there. So this, what I call the third-party security challenge, is it's a fascinating party because there's a ton of people that show up to this party on site. So I went and talked to a major SaaS provider last fall. It's a SaaS provider that probably everybody in the room uses or your customers use. And I was curious because they were one of the first folks I saw that were running New Relic in production. Does everybody know it? Does everybody know what New Relic is? Okay, I see a lot of no's. New Relic is one of those libraries like GigIF, for example. It runs on a huge chunk of the Alexa 20,000, and it's growing like mad. And essentially what it is these folks took the traditional performance management software and your things like T-Leaf that are very heavy, and they made lightweight JavaScript libraries and server-side components you can drop in to do performance monitoring. And essentially you drop a siphon into the DOM, and they send back all these metrics to their SaaS platform, and they do all the analytics for you. So it's really cheap and lightweight for the business, and they get performance analytics out of the application. And the security teams aren't even aware this is there. And the reason that's important is because if it's misconfigured or there's a bug or problem, now everything inside every user session is potentially exposed and being recorded by New Relic. So obviously there should be some controls in place around that. And I went around and started talking to CISOs that were running this, and the consistent pattern was in every single case, not a single CISO knew that they were running New Relic in production. So I asked the CISO of this particular SaaS company, I said, what was the risk profile by which you made the decision that this was a safe and sound thing to do? And he said, well, I'm going to answer it a different way. He said, basically, I'm going to tell you that I think about 90% of the organization probably doesn't know what New Relic is, but I'm sure that 99% of the org doesn't know it's running in production. So this is an example. There's all these different components, and why that's interesting is over the last year, we're starting to see breaches publicized. And when I go talk to orgs, these things are never in scope for their penetration test, which seems pretty fascinating. So one that was compromised last fall was Instart CDN. Have any of you heard of Instart CDN in here? So they're like the fastest growing CDN out there. They're about a year old. They've raised like $70 million. Business owners love them. They sell directly to business owners. And so they're flipping their web content over. And the reason why is it's good for business. It appears to be a very fast, high-performing CDN for cheap. What business owner wouldn't like that? The problem is that that particular CDN, they were moving fast. They were a brand new startup, and they had no security controls. So when the attackers figured out they could exploit them, it led to them, it was 1,062 organizations had all their web assets hosted by Instart compromised. So those vulnerabilities were exposed for quite a while, and people doing pen tests for the particular companies got compromised were not picking them up because no one was going and hitting the content that they thought they weren't authorized to on the CDN. So some more of the interesting dead bodies that happened last fall. How many people in the room know what Giga is? Anybody heard of Giga? So Giga is one of those libraries that's everywhere now. Probably your organization runs Giga somewhere. It probably might run it in dozens of places. They're basically the login as Facebook people. If you ever see login as Facebook, login as Twitter, and they're another one that goes and sells directly to the business. So they're essentially an authentication bypass vendor. They give a new way for the business to handle auth, and the security teams never actually know that that's there and can potentially subvert some of their other controls. And Giga's whole sales pitch is that if you let them handle your authentication, they'll give you more info about your users than you collect natively. Of course, then in return, they get to sell all that info back to all the social networks. So they just get to print money with that. Unfortunately, Giga's hosting was also insecure. And a couple times last year, the Syrian Electronic Army found it. And these are the only ones we know about. They were hacktivists, so they didn't really do that much exciting. But essentially, you could go in and edit the files. And they just went in and edited one line of code and redirected where the Giga library loaded one of its components from to load their hacktivism message. But they could have loaded anything they wanted. And again, this should be a trivial thing to pick up in a pen test, but it can completely subvert your attack surface and expose your users or customers, depending what it is. The other piece that I wanted to share with you on this is when we think, I'm going to talk predominantly about web today, but mobile's an interesting one too. And the reason I bring up mobile is this is a great way to get into an organization in the old-fashioned way of when we used to leave USB keys or CDs, out in parking lots and things. How many of you have left the CD in the parking lot that says Q4 layoffs that you have your malware on? Any of you guys ever do that? Or that you label the USB key? So mobile apps are a great way too, because users will download anything. And this is just a placeholder to remind me when the Snap. You remember the snapping last year when Snapchat got compromised? It was essentially an intermediary, right? Which begs the question, what should the scope of testing be? And they first tried to say this was all out of scope for them. But their API was fundamentally wide open, and so people were abusing it. But we went out there and started looking at the scope of the problem. There were 674 rogue Snapchat applications out there when the snapping happened. And most of us don't realize how big and wide that ecosystem is. But it's a great way for us to enter as pen testers. As defenders, we have to keep an eye on that as well. When we're doing pen testing, social media is also another wonderful place. In this case, this organization had a giveaway account for promotionals. And some bad people compromised and took it over, and no one was paying attention to it, and they made it what I call a reverse gift card giveaway. What they did is gave you a piece of malware that then gave them access to your bank account, so you got to give them money instead. And so these are great as well to put into your scope. So these are the things to think about at a high level. So now let's dig into what we actually need to do this. Let me see where I'm at slide-wise. Oh, good. So this slide always kind of makes me chuckle because, agencies, government agents aren't known for efficiency, but it took them 3 weeks to find 265 instances of deprecated SSL. So the things we want to put in an inventory is essentially we want to map out our known assets, including the third-party, shadow IT, and M&A. So how do we go about doing that? Well, the first and most important way to do it when we do a pen test is I want to look at how to do this fully targeted from an adversarial mapping. So we have 3 tiers of adversaries that we want to think about out there. We have the random opportunistic, which are bots and worms. We have the directed opportunistic. This is the Secret Service verbiage from years ago when they used to work with Verizon on their data breach report. So you have random opportunistic, which is bots and worms. Directed opportunistic, which is essentially script kiddies, or people running automated scanners. The difference between the two is bots and worms don't authenticate. Script kiddies will actually log in and they'll run a scanner, that sort of thing. And then you have fully targeted adversaries. It used to be we didn't see a lot of activity from fully targeted adversaries. And that's completely changed in the last year or two. I think we're all seeing that now with extremely well-funded, organized adversaries. When I talk to orgs doing red teaming today, and even some of the consultancies that have a lot of juniors doing scanner jockey work, I'm always fascinated that when they talk about the scopes are being set by the clients, or by some middle manager guy at the consultancy who's trying to sell a lot of deals and close them quickly. And there's a lot of scanner jockey work. It's like, go test this many assets, go see if you can get through here to the domain controller. And what I don't see is a lot of framing of how an adversary would actually go about attacking the organization. And that's one of the key pieces I wanted to drive home through this. So when an adversary starts out, in the breaches that we've been helping customers evaluate, the first step that we find that they do isn't actually doing the traditional network map and port scan. It's making a list of all the actual businesses is step 1. And then under the businesses, it's listing out their corporate strategies and then going and looking at their acquisitions. The adversaries we're facing today, many of them are playing the long game. And our pen testing, I'm seeing in many examples, our pen testing and vuln management is not taking into account this long game. And by that I mean is these folks are going in, the adversaries are going in and they're profiling acquisitions and they're pre-compromising them before they get merged in the network. We're seeing this over and over again in the last year. And they're also profiling humans and execs because phishing is still one of the number 1 ways in to get their malware distributed in. So the first place we should create a scope for an actual digital footprint is mapping out all the organizations and the humans and what assets they use. Step 2 is traditional network mapping. And I'm not going to go through this in a lot of detail because there's tons of presentations on this. What I'm going to do at the end is, once I get fully through this, I'm going to publish a survey on SurveyMonkey, and I'll give you my contact info at the end. If you're interested, I would love for you to do the survey on SurveyMonkey and tell me what you want more of as info. If you think these things aren't explained well enough, I will put more info breaking down how to use all these. But I think probably everybody knows how to use Nmap. Does everybody in the room know that you can use Google and to some degree Bing to do some passive mapping of hosts, of services exposed? Does everybody in here use Shodan for fingerprinting software? Okay, so there's really good presentations out there in last year for Shodan. And then we have traditional Google hacking. When you're doing your profiling of an organization and you start mapping it out, do any of you use your Google hacking to actually look for binary docs that have sensitive information in them? So that's an interesting area where I find that quite a few organizations are not doing that, or it's not in scope, and I know it's time consuming. But just this year we've had 2 organizations that we found that published lists, one in a Word doc and one in an Excel file, that they had an entire list of user IDs and passwords for a critical application, and another had the connection strings and passwords for all their internal databases. And through misconfiguration, they were both just exposed to the internet, hanging out there, and could be found through Google mining. So that makes pen testing really easy when they just hand you all the creds. So I want to stress this again. One of the most important pieces that is often not in scope, you have to work with your customers or your internal teams to kind of understand. And security is usually the last to find out about this. So you have to proactively have a system by which you're out there Googling, looking for S4 documents. That's the filing. There's an intent to acquire. There's going to be an S4 doc. And then once the acquisition is going through, there'll be a Form 8K. And I believe it's Section 9. It's Section 8 or 9 of the 8K form. They list the assets that the organization will be accountable for, and a date by which the organization is now legally accountable for if those assets are breached or compromised. So these are some good sources of data to find this out. And the reason this is important is we're seeing where nation states are going into subsidiaries the minute they're going into acquisition targets the minute it's announced, and they're compromising them. And we've had cases where they've been going in and they compromise systems that are unlikely to change quickly, like conference room PCs are the last things that are going to get swapped out, things running the TVs. So they go in and compromise and put their malware in there, and they just sit and wait. And it might be months, but eventually that gets plugged into the corporate network, and then once they're inside the parent company that had an otherwise hardened perimeter, then they're off to the races inside. We also find, this is actually pretty shocking, we've found a number of cases in acquisition where the company being acquired provides a list of assets to the corporate parent that they have, and those lists aren't actually complete. And they won't actually have all the applications. In fact, sometimes it's like there's a guy in there that knows exactly what systems won't pass PCI, and those just get erased out of the spreadsheet. So that's the number one thing we've been finding people are getting compromised through that need monitored. And then the second one, which I already brought up earlier, was third-party components. And the pieces we want to inventory all of those is we want to inventory all the things that we have externally hosted. We want to inventory what CDNs we're using. What server-side components, so we can do known weak component analysis. That's always one of the top things I use to prioritize pen testing. Where are they running PHP? Do they have any, externally exposed that points to their internal network? What third-party libraries are they running? And then the last one is weak partner connections. And, an example in here is, how many of you are familiar with Eloqua? You ever heard of Eloqua? Okay, so this is another one that a lot of companies run, and I'll use Eloqua in past tense. I'm gonna assume that they're secure now, but at one point, Eloqua had some challenges around, SQL injection and being able to run, arbitrary code on their systems. What happens is people set up Eloqua that don't want to manage a lot of their marketing content and campaigns, and they'll plug it into their website. And then what happens is the data actually goes to Eloqua, and they process it and do all their marketing stuff. And then they'll often turn around and pass it back either through the front-end web app, through an API, or sometimes right back into the back end of your own systems. And so what happens in these situations is usually IT doesn't have a lot of involvement, security doesn't have a lot of involvement. Eloqua will actually block scanners and security testing. And a lot of the contracts they have will not let you do any testing, but yet they're now an ingress point, with an untested trust boundary that often goes back into one of your internal databases. So attackers would go into them, from your website, they jump into Eloqua and then jump back into the internal database. And usually with our web app scanners and things, we don't, when they're explicit allow, we don't go off and crawl and test Eloqua. So these little things are left out of scope that we've seen lead to large breaches in data. And File's a tool you can use to do that. So I listed out M&A. We talked about third party. Again, stepping back. Who is my target? And so when I want to go do pen testing on a digital footprint, I actually don't enjoy the CTF game that just get to the domain controller, see if you can get some creds. Like, who's the actual target? Who am I going to compromise that I'm going to use to get data and actually steal something from the company or impact their business? Actually demonstrate to them that you can impact business or loss. So obviously we want to go for execs, and we want to go through the M&A targeting. The results of these can be pretty disastrous. I gave you the example of the pre-owned attacks. There was a couple years back, there was a Scandinavian kid that was using OSINT recon, and he found ways that he could brute force and get access on certain systems to filings before they were actually released. And so he went and started doing market manipulation around this, and eventually he was arrested, but he made a lot of money in the meantime. For the companies involved, though, it's extremely disruptive, and it really screwed up some acquisitions and hurt things. So these are essential, actual, real business impact issues that I find are often not covered today. So once we have those profiled, then we go back, we network map, we do all the traditional network mapping on all the third-party components in the merger and acquisition. And then we're going to add in OSINT sources. And these are things you're going to do predominantly with search engines today. You really need the ability to crawl the web at scale. And since there's not many tools out there to help you do that, you're going to start with search engines. But to make an accurate digital footprint, the pieces that are pretty essential to me are, I want to know what all the actual brands are, what the brand terms are, and start with their domains. That's number one. Second, I want to know what the keyword groupings are. I want to get the marketing department to tell me. They're the things they're putting in search engines, etc. and I want to know what all their logos are. And then I want to find all the places those are used on the internet. And then from there we can pivot around those, and I'll get to that in a second. I also want seeds. So one thing that's pretty essential to me for maintaining this for pen testing, and in an external pen test as a consultant, you don't usually get access to internal information. But if you're forming a partnership with the organization, you should absolutely ask for it. So one of the best places to get that information is referral logs, and also get URLs from email. And eventually you can work with an org to whitelist what's internal or intranet. And the reason these things are important is if you get refers, you can mine through, and if you start finding things that are not their assets, they're using their logos and things like that, and see things getting pulled in through refers, you start finding hidden iframes that'll show you what assets are already compromised. The URLs from email are going to help you find a lot of things like what the developers are out setting up in the Amazon cloud, for example, because they'll pass around links to each other, or they'll pass and share Amazon keys. So you want to get all this extracted out dynamically and build it in a database. Same thing with mobile app names. So some more OSINT recon on top of that. We're putting all this in a database. The next thing we want to do is we want to find out, again, place we've probably gotten this from are URLs from emails. We want to find out where their developers are going, where their tech support people, where do their DBAs go for support forums, where their desktop support people do. Just 3-4 weeks ago, I was working with the pen test team on an engagement, and we found that a developer, she had logged into the Oracle Developer Network and had uploaded entire database dumps into essentially what was the public forum. You just had to log in, and those database dumps included all the user IDs and passwords for the applications. So again, that's pen testing made easy. We spend all this time trying to, increasingly it gets harder to find things like SQL injection, and it's blind, and we can have a really hard time doing that, or we can go to the Oracle Developer Forum and just get all the user IDs and passwords and log in. The next one, public source code repo mining. And I want to stop right here and ask so far, how many of you are actively mining today? How many of you actively go out and mine tech support forums that the organizations you're testing or work for are using? Are you doing any monitoring? Okay, I see a couple hands. That's very cool. How many of you are monitoring public source code repos today? Okay, see a couple hands. This has actually been one of the biggest ones I've seen lately, and what's happened is couple of the orgs I work with that do pen testing have customers that have increasingly gotten their network perimeters hardened. So it's harder and harder for them to hack in. They're more aware of phishing, etc. And so they have to become more and more creative to break into the organization. And this is the same thing that we're seeing adversaries in Eastern Europe do. They're monitoring the public source code repos, and the kind of things we're looking for is we'll find this all the time. We'll find hard-coded stuff in the code, like passwords, connection strings. We find hard-coded cloud keys, which give you full access to everything. The developer keys they'll either be hard-coded or they'll be attached inside the public source code repo. Obviously, you can find traditional web app type vulnerabilities simply by looking through the source code. Another thing that it gives you is, if you're doing multi-user role testing and you want to find authorization issues, you can actually look at the entire auth model if the whole app's uploaded in a public source code repo. And one example of this is we had a bank that had called up and said, hey, they were pretty upset because they're like, our pen testing firm and our AppSec firm is telling us our app has no vulnerabilities. We're combing through this thing, we're hammering this thing. Our customers cannot use our application because it's serving up malware. But there's no vulnerabilities in it, so somebody's wrong, somebody's missing something, what's going on? And we were looking around the app, and the app was actually extremely robust for a web app. And it was like, actually it looks pretty good, didn't have a ton of functions, it was definitely serving up malware. And so we start talking to them, they're like, well, it had to come in this way because there's no traffic anywhere else. And they had inline IPS, they were looking at their web server logs. As you can probably guess when doing this testing, again, going back to collecting the right info, after asking them a few questions, it became clear they weren't logging any post data. And their IPS wasn't looking at post requests. They didn't have any post requests in the log, which is normal in a web server log by default. And the reason I was curious is because they just popped up a bunch of brochureware that had login forms on it. It was just marketing registration brochureware. Register here to get our email. Well, long story short, what had happened is as part of consolidation and cost efficiency, someone had gone along and taken all that, the new brochure where they were stooding up, and they plugged it into the production database that served the primary banking application. So then the bad guys came along and popped the marketing sign-up forms and found they were in the database. They just littered the database with malware. I don't even know if they knew they were into the main banking app. And so the banking app was fetching malware from records and serving it up. So there's no ingress or egress through the primary app. It was the shared data source. But these marketing apps had been set as outside of scope for penetration testing because they weren't important. So I'm sure you've seen this before. Obviously, we need to profile and look at these things. And the template for the marketing apps was up in GitHub. So some GitHub fun. Wanted to give you a live example here. This one, I think Chris Nickerson put this query together, but just to give you an example of the amount of interesting things you can find in GitHub, in running about a 30-second query, we found over 356,000 things that look like they're hard-coded user IDs and passwords inside applications in GitHub. So it's pretty easy to refine this by organization, by your brand, by your developer names. So let's go a little further into the things that we want to capture. Search engine mining. How many of you actively today are using search engine mining on a recurring basis to manage your pen testing program or your digital footprint? Gillis, I'm sure you are. Okay, Adam. So there's lists of Google Dork strings you can use to put this in and automate these with scripts. A great toolkit if you're not using it, and there's a presentation from a couple years ago around how to do this. Is Bishop Fox wrote a tool called SearchDiggity that has a bunch of different search engine mining components, and it also has binary document analysis to look for a lot of common regexes. And you can add your own, employee IDs, this sort of thing, but it's going to look for socias. What you want to do is you're building this profile, and I'll get to this next, but you want to have an inventory in your digital footprint. You actually want to have who's using what external email addresses where, and domain names, and I'll show you how we pivot off that in a second. Doc leakage. The other piece that we're seeing search engine mining used for today is if you're doing physical security, you can extract a lot of geofencing or geolocation out of the metadata from pictures, identify locations. The reason that one's actually interesting from a pen test is, I'll give you a concrete example. We're doing a pen test on an org, and their most interesting and sensitive federally regulated information is they did a lot of AIDS testing. And the AIDS testing facilities, because they'd had problems with failing pen tests before, had been isolated onto separate physical networks. So they had the physical buildings where they did all the AIDS patient testing, and in there they had computer systems that were isolated and not on any of the other networks. But what happened in those buildings we found, so we were able to get into the main corporate network and they didn't care. Everything we got, they go, oh, we actually don't really care. But what they really cared about was that information. Well, all those buildings had lobbies, and all those lobbies were running the same key card system that the vendor had installed with SA and set SA to a blank password. It was running Microsoft SQL Server, which is listening on the network, and they ran Cisco's IP telephony phones. So all you had to do was go in and plug into the Cisco phone and then pass their magic packet, and get on the VLAN, and then you could see the door access control server, and then you could open it up and you could walk in and then just walk out with the machines with all the AIDS patient records. So the physical doing this geofencing is how we're able to find the locations of the actual buildings that have that sensitive data and get into it. So the pieces coming to the end here, these are the biggest chunks I'm about to get into that I see missing from programs that can give you a lot more accurate visibility into the assets that they own. How many of you today are doing who is mining to find assets in your portfolio and your organization? Oh, we've got some folks out there doing it. Okay. This one's pretty underestimated. So when you get your list of domains and refine that, all the domain assets you own and all the host names, then the next step that you want to take is you want to go out there and you want to mine who is, and you want to find every contact that's listed out there with those and treat those as assets as well. One, you're going to find some interesting stuff. There's some stuff that's registered to people that probably shouldn't be. The second thing is once we have all that OSINT information, we want to take that list of people, their names, their email addresses, their phone numbers, and we want to go back through who is. We want to go back through Google, and we want to go back through Bing, and we want to mine, and we want to see what else they're attached to. Because when we start doing that, patterns will emerge that are very interesting. So an example was we've had a couple cases where we found organizations where rogue mobile apps were being used to compromise users, particularly in healthcare and in the insurance space. One of the demographics they're going after was like 45 to 75-year-old males, because the ED marketing firms, the erectile dysfunction drugs, will pay like $20 a record. It's very lucrative to get that stuff. So we found this pattern where there were these apps, and the security team thought these apps were legitimate. They were extremely professional. They were well made. They were actually better than the legitimate application the organization had written. But once we pivoted off, we saw that the authors who were publishing these had published these for like 20 different healthcare and insurance companies. And it was all the same person who kept publishing these apps. So obviously, your spidey senses should start tingling when you see that sort of thing. So this gives us the pattern. The other one that we found that was really interesting, while initially creating this profile for an organization to map out all their assets, we actually found a group of employees that had registered a bunch of assets. They had domains and web servers out there that we went and looked at them, and it was really weird because it looked like a competitor. And what it turned out to be, long story short, is there was a group of employees that was getting ready to leave the organization, and they had started up a smaller firm that they were to compete with the organization, and they'd registered all the assets using their corporate email addresses. So we were able to find all the assets that they'd set up in this competitor they were getting ready to launch. It was gone about a month later. How many of you in managing your red team or pen test use a passive DNS database? How many folks in here know what passive DNS or PDNS is? Okay, handful of folks. The threat intel community makes extensive use of passive DNS in profiling attackers' infrastructure. And usually if you have somebody in your SOC doing incident response or some threat intel work, they probably have access to a passive DNS database. They're getting it from someone like Farsight. There's some other projects out there launching to give access. They might be getting it from my organization, from RiskIQ. The importance of passive DNS is, I guess since we're not using it, I should probably back up and say what it is. Passive DNS includes two sets of things. You have historical passive DNS, which is where people are really going. What are they requesting? What are they going to? And then you have current records, which is what people register. So it's like what you get from Farsight. What are new domains that are registered? So there's domains that are actually registered out there. This is how you find new things popping up. If you're marketing, do any of you have marketing teams that sometimes set up promotionals out on the internet that you don't know about? Okay. One org I work with had, I think it was February alone, they got breached twice in a row as marketing set up campaigns collecting PII. And they set them up, of course, on top of WordPress. So it's just set your stopwatch until it's breached. And so how do you find these things? Well, passive DNS is one of the best ways. You get new domains registered, and you also see where people are going. And so you can buy it externally. And again, the two other best sources of passive DNS are going to be domains you extract out of referral logs. That's going to be more for indications of compromise, and where your users are actually going. You can get that out of email. If you have an email system, then you can scrape that out. An easy way to do it. If you have outbound proxies, you can get a lot of it there. Some of your endpoint protection are moving towards will allow you to extract that information out. And I'll give you an example that hit home for us. How many of you work with organizations that do some form of rapid or agile development? Web development? Okay. For how many of you does that mean it's just the organization's way of getting the code from the developer desktop to production as quickly as possible, and then test on the end users? Okay. Are your organizations doing running builds? Is anybody doing running builds right now? They have concurrent running builds. Do you do auto deployment? Okay. So we at RiskIQ, we have been specializing in trying to solve this problem for organizations of identifying these assets that spin up that you don't know about, you don't have control over. And again, security team, some think they have control over it. You start showing them all this stuff, it's usually pretty eye-opening. One of the most critical ones through passive DNS, we actually had the same kind of challenge, and this is what got us really interested. A while back, we had one of our large financial institutions as a customer went through management change, and then all of a sudden, post-target breach world, someone freaked out. They were going through vendor management, and they go, oh my God, we've got a vendor that doesn't have an active disaster recovery test. We try to explain to them the information we're collecting and giving them to them is all OSINT. And so we can recreate it on the fly. But nonetheless, they were like, oh, you've got to do this thing immediately, or you can't be a vendor anymore. And so So one of our folks in engineering went and configured our auto build systems and pointed them at the Amazon cloud. And boom, turned it loose, and so it started spooling up all these copycat nodes in the Amazon cloud. Luckily, these were dummy test systems, but we spooled up like 16 nodes in the Amazon cloud. Well, the auto build server, nobody had set up that auto build server with any of the configs that we run our production software on. So it was all default configs. And so literally within 24 hours, bots had already compromised all these nodes we'd spun up in the Amazon cloud. Bots had already compromised them before the IT team had even gotten to them to start configuring them and using them. And so the question is, how do most organizations find that? You know, how do you keep an eye on this stuff? I mean, that's how fast it can happen. And again, the answers is, you know, how are we going to find it for ourselves? We're going to find it when someone registers a new domain and ties it to it, or in the case of this, extracting out links that people pass around and hand around in email. You know, we extract it from our email, and then we send a browser to go out there and look. Or an in-map connection, you go out there and make an HTTP request, connect and see what's living there. And then we raise a flag when we say, oh, you know, there's live stuff there nobody knows about, or that's not running the right versions of software, et cetera. We need to go look at it. So all the information I've just laid out, you want to put this into one database now. You want to use it all together, so you want to have one silo. You want to have all your domains, all your web infrastructure info, all the passive DNS that your SOC and IR folks are using and their OSINT, the list of users and all that. You want to have your logos and all your brand keywords. If marketing's running some brand protection monitoring, they might already have a lot of this data. Marketing might use someone like a Mark Monitor who's out there scanning around looking for, you know, colliding domains and misuse of logos and all that. You can pipe this in and then compare that to your list of known database. Some of that stuff in there will be yours, marketing knows about, and you don't. So that gives you control of SATO IT. If we automate all this collection and monitoring what's new, we can now delta off of it. Instead of this very heavy one-time engagement, we can start alerting ourselves to simply when new things pop up or change. So it becomes a much more iterative process, easier to manage. So we've been through most of the agenda now. The final piece I want to talk about is a different way that we could move towards doing pen testing together. And that if we build a system this way that can do this dynamically, we now don't have to treat the annual pen test with this upfront large scoping engagement. We certainly should probably have some third party do some annual checks and balances, just like we do an audit or double entry bookkeeping reviews. But as far as actually testing adversarially, your adversaries are not waiting to give you a once-a-year health check. You know, the Chinese are monitoring you, or whoever your adversary is. Maybe it's someone in Eastern Europe or Brazil that's figured out how to monetize attacks against your organization. When you set things up, when someone in your org, the marketing people, for example, the customer I mentioned earlier this year had the 2 marketing campaigns that were popped. They ran to security and said, hey, we need help. And security's like, well, there's one problem. We don't even know where these are. We don't have creds to log in. Right? The adversaries aren't waiting for the security team to put these into the authorized scopelets for pen testing, obviously. So by having this data now, you can kick that off. And so we've been able to help some banks put this in place. So when we see things change in properties around an asset, they need to go pen test that thing immediately. There's certain properties that are indicators of compromise. When they see new stuff spin up, we had an organization, we had one of the largest security product organizations out there. I won't name any names, but they're one of the next-gen vendors. And we were helping them map this out, and they said, well, your data is all wrong. And I said, well, why is that? And what happened is we found 4 main line of business applications running on top of Rackspace, and they were not running on top of software known to be terribly secure. And they said, well, your data is wrong. We have a policy where we don't allow employees to put anything on Rackspace. And so we had to explain to them, well, that thing about firewalls is, the thing about policies is policies work really well when you can put them in a firewall and stop users from going somewhere. But policies don't work really well when your marketing people can pick up the phone and have a credit card and call a creative agency and have them build something, on Rackspace and run it. And so all their perimeter access controls obviously didn't give them visibility to this. But if we simply were extracting out these links from email, whitelisting our internal stuff, or even checking refer logs, because these campaigns linked back to other assets that org owned, they would have known about this a long time ago and already been able to go out there, get control of them, move them to somewhere secure, pen test them, whatever they needed to do. So this database will give us a way to get a handle on shadow IT growth in the cloud. So I want to end this. So we have enough time. I may do a live, show you some live demo stuff. But the important thing for me out of this presentation is there's a couple different levels that I could go with this and going forward. I could do some more hands-on, deeper workshop and show step-by-step how to actually collect all these pieces of OSINT and put them in a database and query and use them. I was kind of unsure what the depth and of experience in the crowd would be today. And the other pieces is I've been trying to think about what pieces might be useful to publish for the community to help you enable your own programs. So how many of you today, as part of your pen testing, do DNS brute forcing? Do you actively do any DNS brute forcing? Use something like Fierce? Try to figure out what's out there for your org? A handful of you do? Okay. So the lists that come with the DNS brute forcing tools are pretty small actively. So how many of you that are doing that sort of thing, would it be useful for you to have like a monthly updated, like top 2 million host names active use on the internet you could use to brute force against your own domains? Would that be useful to any of you? A couple of you? Okay. How many of you would like to have access to some kind of lightweight general passive DNS database that you could use to mine and find the actual host names that are registered to your org that may be beyond the scope of your perimeter or outside your ASNs? Is that something that would be useful in your pen test practice? See a hand? Okay. All the OSINT that I just rolled through, how many of you currently have some type of a workbench or dashboard that you keep all this data in that you can use it actively in your pen testing efforts? Does anybody have a system or a piece of software they use to manage this today? Okay. So I'm going to stop here before I jump over into showing some of this data. Any questions at this point? No questions? What piece of this OSINT and this was the most new or interesting to you that you hadn't thought about using in your penetration testing? Someone want to throw out an example of one of these? Yes, sir.
I had no idea about the SQL file information.
Okay.
So that was very helpful.
Okay. Anybody else? Did you have your hand up? Oh, okay. Yeah. Mining proxy logs. Another way, this isn't really OSINT, another little dirty trick I've seen used is for those of you deploying some sort of host-based agent, Tanium, whatever it is. It could even be patch management. I've got a couple orgs now that mine all their developed machines for all their cloud keys, all their Amazon and Azure keys, and they automatically grab those keys, and then they have a system like our system that they'll then automatically go out and log in and see what content is there and do some analysis on it. So that's another little trick. But PDNS and refer logs are the easiest way to get that. So the biggest gap that I consistently see is most of the assets that we find that people don't have are available through Whois or through passive DNS databases. And when they're getting breached through these pieces that they've missed, almost every time we find these assets through PDNS or Whois mining, and that's the majority of it actually. So we could stop here right now. Would anybody like to see an example of a live data set like this and how you'd come through it, or shall we break here? Anybody want to? Okay. How many minutes do we have left? 5? Okay. All right. I'm back. Okay, so if you create a database of this, for example, these are the kind of things when you'll go in and see. So interesting stuff. I'm going to come in here and one of the, it's not let, oh, okay. All right, let me see if I can. Yeah, I don't know if I'm going to be able to format this for this screen. So, about, is that legible? No? Okay. Well, how about this? If you want to see how I will sort through this in a live database of OSINT info, where you can quickly sort through like what all is on what ASNs, what server software properties are running, just grab me after this and I'll show you, and we can see it here in a view. That the size of this dashboard is a little too big for presenting at this resolution right now. So I'm going to stop here with that and give you back your time. Thank you very much for coming today. Hope this was helpful for you.